vectors. So yesterday we talked about vectors are drawn as arrows. You can show the direction with an arrow. You can show the magnitude with an arrow by how long you draw it. Okay, so today I just want to make sure everybody's clear on how you're going to use trig. We use trig to break vectors into what we call...
I gotta make some copies. I got an 8 in there, though.
Okay.
I'll be right back.
No problem. So you can use trig to break your vectors into what we call components. So this is like basic trig. I'm assuming everybody's solid on this. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. You guys learned this? SOHCAHTOA, right? That's how I first learned it. SOHCAHTOA, like that. Now, if you know two sides of a triangle, look. Let's say you know side A and side C. You should be able to figure out the angle. So let's just say A is like 7 meters, and then C is like, I don't know, 15 meters, something like that. How would you go about solving for this angle? You're going to have to do that a lot. So here you got to use what we call inverse trig. So let's see, we have adjacent and hypotenuse. What's adjacent and hypotenuse? Cosine. So you're going to go cosine inverse. Adjacent would be the 7 meters. The hypotenuse is the 15 meters. And then make sure you're in degree mode on your calculator. In fact, I'm not even kidding you. Today alone, 4 different kids throughout the day, because I have the answers to the worksheet written on the board, 4 different kids were like, I'm not getting those answers. Do you want to know why they weren't getting the answers? They're in radian mode. If you take your quiz or test and you're in radian mode, such a bummer. I'd put a little sticker on your calculator, little sticker so you can remove it later if you want. Physics equals degree mode. You got to be in degree mode the entire year. You will never go to radians. Okay, so what else? You should know Pythagorean theorem, right? A squared plus B squared equals C squared. You're going to use that a bunch. Okay, next screen. That's enough about trig. All right, next screen. Now, this screen, here's what's going on here. We have vector A, see vector A right there? And then over here we have vector A. These vector A's are identical, but I just want to show you how you can draw components in 2 different places. So the components of a vector make up the total, right? Any vector is going to have X component, Y component, if it's not already perfectly X or perfectly Y. So let's look at this diagram here on the left. Look. So we got vector A, so this right here is the X component. This right here is the Y component. If you add the X component and the Y component together, you're going to get vector A, right? Now notice the X component and the Y component, notice that they are tip to tail. So if you add the X component and the Y component, what are you going to get? Vector A, right? Called the resultant vector. The answer you're looking for when you add vectors together is the resultant. And what's always true about the resultant? It goes from the tail of the first to the tip of the last. So that's like a little exercise in vector addition right there. But now, how would we go about calculating these components? Well, look, if your theta is off the horizontal, right? The horizontal being this, right? Here's the horizontal. If your angle is off the horizontal, it's going to be like this. Now, the key difference between these 2 diagrams, when it really comes down to it, this theta is off the horizontal. This theta is off the vertical. See that? That's really the only difference between the 2 diagrams. Now, how would we go about getting A sub x, the x component? Well, look. Cosine of theta, so what's cosine? Adjacent, which is going to be A sub x. The hypotenuse is A, so doing the algebra, A sub x is going to be A cosine theta. And then for the vertical, for A sub y, you go sine theta, so what's sine? Opposite, which is A sub y, over hypotenuse, which is A. You do the algebra, A sub y is going to be A sine theta. Now, all of this changes if you're using the angle off the vertical. So now come over here. So now A sub x is up here. is that the same a sub x as before? It is. You know, remember, you're allowed to move vectors. So imagine like you pick this guy up right here. I'm going to grab this vector. Look at, he is the exact same thing as that. You're allowed to move vectors as long as you don't change the direction or the magnitude. But look, with the angle off the vertical, notice that a sub x is now sine theta instead of cosine theta. It's all the same thing though. So for example, like look, if this theta in here were 60 degrees, if this theta were 60, what would this theta be? 30. What's sine of 30? 0.5. What's cosine of 60? 0.5. So my point is simply this. You end up getting the same thing. Sure. Sure. Okay. So does this make sense? Does this make sense? The key thing I'm showing you is you can show x component, y component. You can show it with your theta off the horizontal, which would be like this. Let me revert this. You could show your a sub x with your theta off the horizontal, or you could show your a sub x with your theta off the vertical, right? And then the trig that you would use would change because your theta is in a different spot. Now, 99% of the time, angles are going to be off the horizontal. This is the way you're going to see it almost every time. On the AP exam, I have seen the College Board give problems where the angle is off the vertical. So it's the same thing, just angle in a different spot. Does this make sense? Okay, now. Okay, so I want everybody to solve this. We got this guy shooting a gun. The initial velocity of the bullet is 150 meters per second. If he shoots the gun at an angle of 40 degrees above the horizontal, find the x velocity of the bullet and the y velocity of the bullet as it leaves the gun. I like to do components in a nice color that's different than the actual vector. So the actual vector here is 150 at a 40-degree angle. So we'll go like with this bluish purple. So what I'm showing right here, this arrow represents velocity in the x direction. This arrow here represents velocity in the y direction. Because if the guy shoots the gun at an angle, the bullet has x velocity and y velocity simultaneously, right? Now, how are we going to get this x velocity? Sine or cosine? So we look where the angle is, right? The angle is right here. So Vx happens to be adjacent. The 150 is the hypotenuse. So what's adjacent and hypotenuse? Cosine. So you go like this. You go cosine 40 equals Vx, which is adjacent, over 150. So Vx is cosine 40 times 150. And this comes out to be 115.0, rounded to the nearest tenth place, 115.0 meter per second. Now, Vy, we're dealing with opposite and hypotenuse. So we're going to go sine 40. All right, so sine is opposite. So that's opposite is Vy. And hypotenuse is 150 meter per second. So Vy is going to be sine 40 times 150, like that. Okay, so and then that comes out as 96.4 meters per second. Now, hey, what if your angle was off the vertical? That'd be kind of weird, but like what if we were given this angle up here? Well, you could show your components off the vertical, same exact thing. Here's Vy, there's Vx. Right? Only here you would be using what angle? 50 degrees, right? Or I guess you could also use that 40 right there. You could do that. Okay? All right. So I want you guys to start on the worksheet, but before you start on the worksheet, everybody look at number 1. This is number 1 on vector addition. I want to explain these angles because they've been a source of confusion. So the first vector addition problem, the two vectors that you're adding are 3 Newton at 45 degrees. Now, hey, what is Newton? Kids have been asking me if that's north. That's not north. Newton, you're going to learn something new right now, which we'll talk about next chapter. Newton is the unit for force. And what do we use for force in everyday life? We don't use the Newton in everyday life. Not many people know the Newton. What do we use in everyday life to measure force? What do we use to measure force? Pounds, right? So like I weigh 200 pounds. Don't tell anybody. I weigh 200 pounds. My kids think that that's like ridiculous. Like, Dad, you got to lose weight. 200's too much. And I'm like, well, I'm tall. That's my excuse. And I like to eat. I like to eat food. Okay. I'm 200 pounds, man. I'm like just under 6'5". Just under 6'5". And I'm packed full of muscle. Okay. Lots of muscle, dude. Muscle weighs a lot more than blub. Okay. What was my point here? Oh, newtons. So on this problem here, so 3.0 newtons. That's a vector, man. Look, there's several vectors that you're going to be dealing with. Let's just name the vectors. Displacement, measured in what? Typically meters. Velocity, measured in meters per second. That's a vector. Acceleration is a vector, meter per second squared. Force is Newton. Momentum is kilogram meter per second. All of those are vectors, but the way you deal with adding them, it's the same steps, okay? Now, what's this first vector here? 3 newtons at 45 degrees. This is what it's telling you. So you got x, y, 45 degrees would be like this. So there's the 3 newtons. Bam, understood to be off the positive x, right? Now, the next one, 5 newtons at 135 degrees. Guys, do you want to be working with angles that are above 90? I don't. A general rule, you want to make your angles between 0 and 90. So how do we get 135 into something between 0 and 90? Well, let's just look at what it's telling us. So look, here's x, y. This 135 is understood, just like math class. Where is it being measured off of? The positive x, right? So 135 is going to be to about there. It's right there. So this is your 5 Newton vector like that, 135. But what's that the same as? 45. Now how would you describe this angle? This 45 degree angle? Don't just say 45, because if you just say 45, then you're back to here, right? That's 45. How would you describe this 45 degree angle to somebody? You would say 45 degrees above the negative x axis. You say that and you're money. That's it. That's like perfect. Or you could say the 135, but when you're giving the final answer to a problem, final answer, keep the angle between 0 and 90. And whatever you do, don't use north, south, east, and west unless that's how the problem is given, right? A big thing I've noticed over the years, dude, kids love to give their angles using north, south, east, west when the problem is given in terms of x and y. If the problem is given in terms of x and y, give the answer in terms of x and y. Does that make sense? Okay, so here's how you're going to do these vector addition problems. There's 2 ways to do it, guys. Graphical and mathematical. I recommend having page 11 in the Spaldo notes handy, because page 11 tells you exactly how to do graphical addition, exactly how to do mathematical addition, but just here it is in a nutshell. If you're doing a graphical solution, you do not need a calculator, okay? You do need to scale. You need to set up some scaling. Like, so for example, for this problem, for number 1, For number 1, you're adding 2 vectors. The vectors are 3 newtons at a 45-degree angle, and then 5 newtons at a 45-degree angle. Now, a good scaling here, and always write what your scaling is. Scaling, I'd say 1 centimeter equals 0.5 newtons. Say that. Okay? So, what you do, so these are your given vectors. You start out by going like this. So pick a point like this. Now, you're going to get out, first off, you're going to get a protractor out, and you're going to mark off 45 degrees measured off the horizontal, right? So here's the horizontal. Bang. Mark off 45 degrees. Then, how long should this arrow be? If this is a 3 Newton vector, and we're saying that 1 centimeter is half a Newton, how long should we make this? 6 centimeters. So you go, bam, just measure that out, label it 3 newtons, it's 6 centimeters long. Then, the 5. How do we add vectors? We place them together how? Tip to tail. Now the next one's going 45 degrees off the horizontal like this. So you're going to go boom, mark off 45 degrees. Bang. Now how long are we going to make this guy? 10, because he's longer. 5 newtons. Okay, so we place them together, tip to tail, show your angles, 45 degrees, 45 degrees. The answer you're looking for, so I'm going to do this in a different color or red. The answer you're looking for goes from the tail of the first to the tip of the last. So this is your resultant vector. That right there is the resultant. How do you convert that into an answer? Well, get out your ruler, you measure this, measure it, and then convert it to an answer using your scaling. And then measure off this angle using a protractor. Yo.
So doing it this way won't give you the exact, like first human error?
Oh yeah, graphical is not very accurate.
And then the mathematical is exact.
Mathematical, your answer should be the same as my answer on the board. Yeah, mathematical is totally on the money. Now, mathematical, let's just talk about how you do mathematical. I promise I'm almost done. How do you do mathematical? Okay, look, so we got 2 vectors that we're adding. The 2 vectors are 3 newtons at a 45-degree angle. That's the first one. And then the second one we're adding is 5 newtons at a 45-degree angle. The first thing you got to do for a mathematical solution is figure out your components. X component, Y component. X component, Y component. So figure out your X components, your Y components. Basically what you do, you add up your X's. So here there's going to be 2 of them. Keep in mind, this guy here is going to be what? He's negative. Why is he negative? Don't forget sign conventions. To the right is plus, to the left is minus, like this. Here's your sign convention, like that. So he's negative, this guy's positive. Add them together, get your total X. Okay, then do the same thing for the Y. Add your Y's together. Figure out your total Y. Once you have total X and total Y, so for this problem, the total X comes out negative, the total Y is positive. Notice, am I measuring things with a ruler? No, that's graphical. Just kind of eyeball this. And then how do we get this answer here? Pythagorean theorem. Because you know your X, you know your Y, you've calculated that. So to get your answer, to get the resultant, you do Pythagorean theorem. And then solve for the angle with inverse trig. Tangent, inverse, opposite over adjacent. Right? So you do it all mathematical. You don't need to measure things with a protractor. Just make it relatively close by eyeballing, you know. But you don't have to be nearly as careful with your diagram as you do with graphical.